Look at the phone in your hand. It's a masterpiece of human engineering. Billions of tiny switches flipping on and off, billions of times a second, speaking a language made of nothing but ones and zeros. But it's blind. It can only simulate the world from the outside. It cannot speak the language nature actually speaks. For decades, the smartest people on Earth have tried to build a machine that could, a quantum computer. And for just as long, nature has fought back. Companies like Google and IBM build their quantum computers out of superconducting metal loops. But the quantum states living inside them, the qubits, are unbelievably fragile. A tiny shift in temperature, a microscopic vibration, a single stray cosmic ray passing through. Any one of these things, and the qubit collapses. The information just gone. It's a war against entropy, and in physics, entropy always wins. To keep just one logical qubit alive, the old approach forces you to build thousands of backup qubits, all of them working overtime just to correct the errors. Scale that up into something powerful enough to actually change the world, and the machine would need to be the size of an airplane hangar or a football field. It's brute force, and brute force has a ceiling. Nearly 20 years ago, Microsoft stepped back and asked a different question. What if, instead of fighting the noise, you build a qubit that the noise couldn't touch? A scientist named Matthias Troyer didn't want thought leadership. He wanted a machine that could make a real commercial impact. So Microsoft went looking for a ghost. In the 1930s, an Italian physicist named Ettore Majorana proposed a particle that had never been seen. Not in a lab, not once. For almost a century, it existed only on paper. A theory waiting for proof that might never come. Microsoft bet on a ghost anyways. In February 2025, they announced the bet had paid off. They called it the Majorana 1. To build it, they didn't just design a new circuit. They had to invent a new state of matter. They called it a topoconductor. They took a semiconductor, indium arsenate, and fused it to a superconductor, aluminum, spraying the materials on atom by atom. One misplaced atom, one single defect. That's all it would take to kill the entire process. Cool it down near absolute zero, hit it with a magnetic field, and something extraordinary happens. A topological superconducting nanowire forms, with Majorana zero mode sitting at each end. Here's the trick. Instead of storing quantum information in one fragile spot, the chip splits in two. It hides the information in something called a parity, shared across both ends of the wire. A stray piece of radiation hits one end, and it doesn't matter. The other half of the secret is still safe, still waiting, sitting on the other far side of the wire. The information isn't guarded by a wall, or a backup, or brute force. It's protected by the geometry of space itself. That changes the math of everything. No thousands of backup qubits, no football field. Majorana 1 holds both the qubits and control electronics together in one chip, and the whole thing fits in the palm of your hand. Right now, it holds just 8 topological qubits. That's it. But it's built on a modular 8-shaped architecture designed from day one to tilt outwards. As Microsoft technical fellow Chetan Nayak put it, whenever you're doing quantum computing, you need a path to 1,000,000 qubits. Microsoft didn't just build a chip. They built the first step on that path. Of course, when you tell the world you've captured a ghost, someone is going to tell you you're seeing things. A researcher named Henry Legg published a peer-reviewed critique in the journal Nature, accusing Microsoft of cherry-picking data and making basic errors in their testing protocols. He didn't say Microsoft was decades away from working on a topological computer. He said centuries. Microsoft didn't back down. They handed the proprietary data over to DARPA, the U.S. Defense Advanced Research Projects Agency. DARPA combed through every detail, week after week, and at the end of it, DARPA selected Microsoft to move into the final phase of their program, to build a utility-scale quantum computer. So why does any of this matter? Why are billions of dollars pouring into a freezing chamber, chasing a chip the size of a postage stamp? Well, it's because of what millions of qubits can actually do. Right now, if you want a catalyst that breaks down toxic chemicals, or a concrete that heals its own cracks, or a crop fertilizer that doesn't poison the soil it's meant to feed, you have to guess. Decades of guessing. Decades of trial and error. One failed experiment at a time. A classical computer cannot simulate the quantum mechanics of a complex molecule. It just can't. The math is too vast. A 1,000,000 qubit Majorana machine could. As Troyer put it, the computer teaches the AI the language of nature. and the AI hands you back the recipe. You wouldn't have to guess anymore. And they aren't waiting around to find out. At their 2026 Build conference, Microsoft unveiled the next chip, the Majorana 2. They swapped the aluminum now for lead, a superconductor so difficult to work with that up until now, humans mainly used it just to block radiation, not harness it. The result was the time a qubit can hold its quantum state surged 1,000-fold, from 12 milliseconds up to 20 seconds. They didn't just hit their timeline, they cut it in half. Microsoft is now targeting a scalable, fault-tolerant quantum computer by the end of 2029. Look at your phone again. You're looking at the end of an era. The age of ones and zeros is closing. The next age right now is being built at the bottom of a freezing chamber on a chip the size of a postage stamp, small enough to fit in someone's palm. And when it finally wakes up, it won't just calculate the world, it will understand it.